In 1766, a London printer called John Spilsbury came up with a curious idea. He took the world and carved it up. Spilsbury's dissectable map was the world's first jigsaw. By the mid-18th century, give or take a few missing pieces, the world had been discovered. Now, with the world at their disposal, Georgian Britons would travel underground and overland, across oceans and continents, to discover the riches that would fuel a revolution. This revolution would make the modern material world, and it started at a very peculiar place, at the tea tables of Georgian Britain. By the early 18th century, the British had become, well, very materialistic. They craved exotic goods, sugar, porcelain, fine cotton, but it was tea that particularly took their fancy. This ancient Chinese infusion first appeared on British tables in 1657. Mid-18th century people of taste like nothing more than to sip this oriental import sweetened with Caribbean sugar. They drank from the finest Chinese porcelain and dressed in Indian cottons, including calicos and chintzes. This was the good life, and everyone wanted a taste. How this dream became a reality is one of the most fascinating adventures in British history. It was an adventure spurred by the search for wealth, and it begins underground with the mineral riches hidden deep in the earth, the most important of which is iron. Iron is a mineral that comes out of the ground as iron ore. Here's a piece. The thing is, to make iron from this, one has to smelt it. That's heated to a very, very high temperature to remove the oxygen that's in it. Iron makers used charcoal, but by the 18th century this was running out. They tried coal. But coal contains sulfur, which, when heated with the iron ore, makes the finished metal brittle and useless. It seemed coal was not the solution, but one man thought otherwise. He had the right idea in the right place. Here, at Coalbrookdale in Shropshire, iron ore and coal can be found in close proximity. Now, this is exactly what Quaker ironmaster Abraham Darby was looking for. Using these, he was able to lay the foundations for the modern material world. This is coke, which essentially is coal processed to remove the sulfur. Now, in 1709, Abraham Darby had a very, very bright idea indeed of using coke to smelt iron. Today, we're using recycled iron and limestone. Originally, it would have been iron ore and limestone. The iron's been heating up in the furnace at a really high temperature, and Nigel's about to untap it, and molten iron will come gushing out. Here it comes. Our eye, I've got to stand well back. Ugh. This is a pig mould in which pig iron was cast. It's called a pig for a very simple reason. It looks rather like a pig with little baby pigs feeding off it. Well, the pig iron's cooled off. Here it is. I'm getting it out of its sand mould. And here it is. Good, strong, usable iron, just as Abraham Darby would have made it. Darby's coke-smelted iron made strong, cheap pots and pans available to all. New techniques improved the quality and reduced the cost of iron. Within 50 years, Coalbrookdale became one of the most industrialised places on Earth. Britain went iron mad, and no one was madder about iron than John Iron Mad Wilkinson. He was a foundry owner at Broseley near Coalbrookdale. In fact, if it could be made with iron, Iron Mad made it. He played a key role in building the world's first iron bridge, and he built iron railways, iron boats, and even iron buildings. People dismissed him as a dreamer. They were wrong. 18th century ironmasters like Wilkinson and Derby laid the foundations of our modern metallic world. But more metal meant more minerals, and mining them was proving a problem. Much of Britain's mineral wealth lay deep underground, in mines continuously flooded, like this one, this tin mine in Cornwall. And here you see the problem, water. To get at the copper, the tin, the lead, or the coal, this water had to be removed. Ironically, the best solution to this flooding problem turned out to be water. In 1712, Thomas Newcomen, a Dartmouth ironmonger, unveiled a marvellous new machine. The first of Newcomen's atmospheric engines was installed near this modern reconstruction at Dudley in the West Midlands. It was called an atmospheric engine because it used the pressure of the atmosphere to create power and movement. This model shows the principles by which the engine works in a rather basic way. This glass jar represents the cylinder, and this syringe over here, the piston. In the real engine, the piston's inside the cylinder, but for our purposes, separate. Now, fill the jar with steam, because it's not cast iron but glass. We can see the steam going in. It looks pretty good. Seal the jar so the steam is sealed in. Okay, now I spray the jar with cold water. The steam inside is being condensed. Now, condensed steam occupies less area than steam, so a partial vacuum has been created inside the cylinder. This vacuum causes atmospheric pressure to force the piston right up there, drawn up, forced up rather, by atmospheric pressure outside. That is how this amazing machine used water and heat to create movement and power. Quite fantastic at the time. Here's the top of the boiler, coal-fired, to produce steam. The steam travels up here, and through that connection enters the great metal cylinder up here, the equivalent of our brass jar. Also, at the base of the cylinder, one can see cold water being injected via that pipe there. That condenses the steam inside the cylinder. Piston goes down, pulls the great end of the beam down with it. That's the action that works the pump, removing the water from the mine deep below. Really amazing stuff, this. The Newcomen engine really is a magnificent beast, absolutely pioneering. One of the most important inventions in the history of man. It was a new source of power. It made it possible to gain access to those minerals, tin and coal, waterlogged deep underground. It's quite true to say that without this engine, the Industrial Revolution could never have taken place. Steam pumped the mines and would go on to power the factories of Britain. But all this steam needed, guess what? Coal. and knowing where to look for it was still a hit-and-miss affair. William Smith was a canal surveyor whose passion was fossils. As he studied the land through which a canal would be cut, Smith noticed strange patterns in the rocks. It was perhaps Smith's fascination with fossils that led him to neglect his work as a surveyor. Anyway, in 1799, he was sacked, and he ended up in Debtor's jail. At the same time, his ideas about rock formations were scorned, and his wife went mad. It's all enough to drive a chap over the edge. Smith took refuge here, Scarborough on the North Yorkshire coast. It was the perfect place to indulge his passion and prove his point. These cliffs just outside Scarborough are a wonderful illustration of Smith's geological ideas. You can see they're clearly formed of horizontal layers called strata by Smith and his geological chums, and each layer contains fossils like this interesting ammonite, a sort of primitive squid. Now, Smith observed this type of fossil, this ammonite, only occurred in one layer, one strata, not in the layer above, not in the layer below. He went on looking and found higher levels, different sort of ammonite fossils, quite different. They changed. It was clear these strata had been laid down from the bottom to the top over a long period of time. It seems very obvious to us now, but that was a new idea. Smith's work provided the first scientific evidence that the world was created over millions of years. It wasn't just of abstract interest. Smith recognized that if the layers, the strata, always occur in the same order, then it was quite possible to predict what lies deep underground. To demonstrate his theory, Smith decided to display fossils in chronological sequence. In 1829, a museum, the Rotunda, was built for that purpose here on Scarborough's seafront. Today, the Rotunda is home to a local history collection, but in Smith's day, it would have been like walking through geological time. Here at the bottom were displayed the earliest fossils from the Deltaic layer, 165 million years old. And here, in the middle, fossils from the Oxford clay, 160 million years old. And right up here, at the top, were fossils from the Hambleton oolite, only 155 million years old. And all around the Rotunda, you can see this splendid frieze designed by Smith's nephew. It shows stratas and layers of the sort we've seen on the cliffs outside. And this is William Strata Smith's legacy, a project that started with cutting canals, ended with a new vision of the world. In 1815, he published this geological survey of England and Wales, the first geological map in the world. And with this map, it was possible to predict where mineral wealth lay below ground. It's very moving. This man, working alone, underfunded, created a key to the wealth of the world. Incredibly, it's not very different from the current geological map of England. In fact, Smith's system is still used today, from finding oil in Texas to minerals on Mars. But despite the best efforts of men like Darby, Newcomen and Smith, there were some things, like tea and cotton, that could never be grown, produced or found on British soil. It was time to look elsewhere. Time to find the missing piece. For Georgian geographers, that missing piece was the southern continent. Some believed that to balance the land in the north and stop the world from tipping over, there must be a huge continent in the south. On the 25th of August 1768, a former coal ship sailor from Whitby set sail on a voyage that would change the world. Captain James Cook's mission was to make an important astronomical observation on the 3rd of June 1769 from the island of Tahiti in the South Pacific. It was hoped that by observing Venus passing in front of the Sun, it would be possible to measure the distance from the Sun to the Earth. But there was another secret agenda. Secret instructions from the Admiralty ordered Cook to sail south in search of the fabled southern continent. This was a materialistic mission. Its aim, new colonies, commodities, markets. Cook failed to find the southern continent. In fact, he was convinced it didn't exist. Instead, he sailed on to New Zealand and the unvisited east coast of Australia. On the 19th of April 1770, land was sighted. While Cook surveyed the coast, botanist Joseph Banks recorded the plant and animal life on shore. So rich was the life he found here that it was named Botany Bay. These drawings show us some of the things they saw. This strange hairy plant was quite new. It's called a Banksia, after Banks, of course. And this drawing is a fleeting glimpse of a kangaroo. Banks was particularly fascinated with plants that he reckoned would have a practical or economic use back home. For example, this New Zealand flax, which the Maoris used to make baskets and is now a common garden plant. Or, more particularly, this eucalyptus, now used in everything from soap to sellotape. Cook's voyage filled in the missing pieces in the map of the world. It marked the end of the age of discovery and, for the native peoples he encountered, the end of the world as they knew it. It also sowed the seeds of the modern global economy. And it was Banks, the on-board botanist, who would help this economy to blossom. On his return, he became the first unofficial director of the King's Botanic Garden at Kew. I've come to Kew to meet plant historian Dr. Toby Musgrave. So, Toby, what did Banks actually do here?
What he did was he saw the economic benefits of setting up plantations. Britain's empire was expanding, we had all these colonies. So he said, well, why don't we put plantations in all these colonies, take plants from A and transfer them to B, and we can make a lot of money.
This is a really, really big idea. So, in fact, he saw the whole potential of the empire as a place really for gathering and nurturing plants.
He sent out this series of men called the plant hunters, these nutters, basically went around the world, North America, South America, Australia, and they brought back all these plants. Some of them are beautiful, some of them are garden plants, like geraniums are a great one there, South African. We have things like the monkey puzzle that came from Chile. One of the areas that Banks saw great potential for was tea, this plant here.
Oh, this one here.
Tea at this time was a hugely valuable commodity.
Yeah.
China had the monopoly, so people over here were adulterating it with iron filings, sheep dung, all sorts of bits of rubbish.
Iron filings? That could kill you, couldn't it?
Tastes foul, I imagine.
But that's because it was so valuable, they wanted to increase the weight, presumably. It's a bit of a ploy.
Absolutely. So Banks said, well, why not cut out the middleman? Let's get tea and grow it ourselves. He couldn't get them from China, but he managed to get some plants from India and try to establish a tea industry in India, which actually happened later in the 1850s, and we still get a lot of our tea from India today.
So all of this wonderful kind of beauty is driven ultimately by commerce.
Green gold.
Green gold, yes. But the biggest cash crop of all wasn't green. It was white, cotton. By growing cotton on colonial plantations using slave labour, this exotic luxury would become an everyday essential. From America and the West Indies, cotton was taken to Liverpool and on by canal to mills, like Quarrybank Mill near Style. Quarrybank is now a museum, and Val Bryant is their expert on textile history. This is the cotton in its natural state, isn't it?
This is the cotton bolls where they get picked, so we get this raw cotton. And when cotton came in, we didn't know really how to prepare it, so we treated it just the same as wool. So hence you get the word cotton wool.
Cotton wool, of course, yes. The cotton wool was teased out and spun into a long, thin thread. To weave the cloth, this was then placed in a shuttle and thrown back and forth between threads strung on a loom. But weaving was an awkward job. The weaver needed long arms to throw and catch the shuttle across a wide piece of material. Oh, and that's the sort of basic problem.
Just like that, it falls on the floor because your arms aren't long enough.
In 1733, a weaver called John Kay took out a patent for a device that would have dramatic results. Instead of throwing the shuttle by hand, Kay put the shuttle in a box. When the weaver pulled a stick, a hammer knocked the shuttle through the threads. It was called the flying shuttle. This, of course, is theory much, much faster, isn't it? Yes, and even as an amateur, I can appreciate this is a huge advance. Flying shuttle. It's absolutely amazing. But as the men wove more cloth, the women, or spinsters, couldn't keep up. Fortunately for them, in 1764, another weaver, called James Hargreaves, realised one wheel could be attached to many spindles. He called it the spinning jenny, meaning the spinning engine. The legendary spinning jenny. I never imagined I'd ever see one, actually. I mean, it's a machine for mass-producing thread, really. That's it, isn't it?
Yes, because you're getting now one person spinning 16 threads.
And presumably this could be extended almost infinitely. It could be 20, 40, 60.
Yes, it did develop to more and more spindles. It's really now taking the spinning out of the cottage system. So you're having building of mills like Quarry Bank.
This is the beginning of the modern world of mass production. In the 1780s, new technology took steam power to Britain's mills. Cotton cloth, once an expensive import, was available to all. By the 1830s, thanks in large part to cotton, Britain was the richest nation in the world. But it was an exhausting business. By the early 19th century, workers like these at Quarry Bank Mill were spinning and weaving for 12 to 14 hours a day. What they needed was a break. The tea break, with its sugar and germ-free boiled water, kept the workers healthy and the looms weaving. But their cheap earthenware cups had a nasty tendency to crack. To prevent this, they poured a drop of milk in first, a habit many of us still have today. In contrast, Chinese cups were beautiful and heat-resistant. Unfortunately, the Chinese kept the recipe for their precious porcelain secret, a secret that British potters were determined to crack. This is China clay, but this isn't China. This is Cornwall. Beneath Cornwall lie thick layers of granite. Over millions of years, this has broken down into a fine chalk-like powder, which is simply washed out of the rock. It's called kaolin, after a range of hills in China. Today, China clay is used in everything from toothpaste to magazines and is Britain's second biggest export. We even sell it to China. And the man who discovered it was an inquisitive Quaker chemist called William Cookworthy. He was obsessed with finding the secret of true Chinese porcelain. In 1746, Cookworthy visited a tin mine in Cornwall. The mine used a Newcomen engine to prevent flooding. When the engine's furnaces needed mending, the workers patched them up using a local clay with curious properties. Cookworthy was intrigued. He came up here, Tregonning Hill, near Helston, to see the source of this clay. This is one of the pits the clay had come from. Incredibly, Cookworthy had found the elusive ingredient for true hard porcelain right here in Cornwall. Cookworthy took his china clay home and began to experiment. In 1768, he produced the first piece of genuine British porcelain. His discovery was seized upon by potters like Wedgwood, Spode, and Corfley here at Coalport near Coalbrookdale. Here we have the china clay. Kaolin it's called, isn't it? And pour some out. It's very fine. This, of course, is the basis of the porcelain, isn't it?
Yes.
And now what is this mixed with?
We add what's known as china stone, which is a very closely related material. You grind them both up to make them very fine powder, like this sort of consistency, and then mix that with water to make a thick, smooth liquid which will pour, and that is known as slip.
And now that's in here, isn't it?
Indeed. It needs well mixing up. Make sure it's a nice, smooth mixture.
And I now pour this
into the mould.
The excess slip is then poured out and the remainder left to dry for an hour. Here it is, adhering to the side of the plaster of Paris. It indeed is a rather wonderful bell-shaped teacup.
There we go.
So, Kate, this very delicate object now has to be fired, so off to the kiln.
Yes, indeed.
After a week in the kiln, the cup is decorated. From the 1750s, hand painting was replaced by transfer printing. A design was engraved onto a copper plate, covered in ink and used to print hundreds of transfers. Using this, manufacturers could mass-produce decorated china, including imitation Chinese designs, such as the willow pattern created in the 1790s by Spode. After yet another week in the kiln, the cup is glazed and fired again. Now this is terrific. It's a beautiful thing, and I suppose it made beautiful things like this available for a larger section of society in the 19th century. These were much cheaper.
Much cheaper than hand painting.
It's a handsome thing. I'm very proud to have been involved in making it. Thanks to mass production and mechanisation, things that were enjoyed by the select few, such as tea, cotton and china, were now available to all. The British taste for exotic goods like tea, cotton and china inspired a revolution. And today, virtually everything you put in your trolley, from glossy magazines made using china clay to tea and tea towels, even the metal shopping trolley itself, is there because of the Georgian desire for the good life. Thanks to a unique blend of mineral wealth, ingenious industrialists and insatiable appetites, Britain had made the modern material world. You can obtain a free poster map of Industrial Revolution sites and events, plus details of all Open University programmes by calling 0870 900 0352 or visit the website at bbc.co.uk/history. Next week, Working Wonders.